So yeah, for 5.2 we're looking at these sum and difference formulas. These are going to be new for you. The good news is at the end of the day they're just formulas. You know, I feel if you can handle things like the quadratic formula and other things of that nature, these are really no different. They're just new. U and V, first of all, those are going to be angle measures, whether that's in degrees or radians. So what they're saying is these two angle measures, the sine when we add those together are going to be equivalent to that. All right, and I'm not going to read through every one of them. You can look at those on your own, but go ahead and copy those down if you need to. Unit circles, do we have those out? Those are going to be helpful today. So the idea behind the formulas today is this. Maybe we don't have the calculator, maybe we don't have the technology at hand, but we have our unit circle. And the nice angles that have always showed up on the unit circle are things like 30 and 60 degrees, which are those multiples of 30, and then also multiples of 45, okay? Also multiples of 90. But what do we do if we get like a degree measure of 95? Is the unit circle still kind of not useful to us? And actually, with these sum and difference formulas, we can use them. So sine of 195 what we want to do is find two angle measures, or this is our hopes, is that we can find two angle measures that when added together will get us 195 degrees. So creative thinking, thoughts, any measures come to mind?
150 and 45.
Let's try 150 and 45. So 195, same thing as 150 and 45. True. And now that we got 150 and 45, now we can use our sum formulas. U and V being that 150 and 45, and we're just going to plug it into this guy right here. Okay? So the next part of that formula was the sine of U, which is your first measure. That was the 150. Times the cosine of the second measure, which is 45, plus cosine of the first measure of 150 times sine of the second. And we chose 150 and 45 because they are on the unit circle. Let's go ahead and look at those. 50 sine y value is a half. 45 degrees, x value there is square root of 2 over 2. X value at 150, negative square root of 3 over 2. And at 45 degrees, our y value is square root of 2 over 2. Multiply and simplify. Square root of 3 times square root of 2, that can be the square root of 6 over 4. So we got the square root of 2 minus the square root of 6 over 4. And there we go. And I actually like that you chose those two values because, again, they add up to the 195. But just to kind of show there's going to be more than one way of doing this, I chose 60 and 135. That's another combination of two angles that are on the unit circle. And, you know, maybe at first different numbers, but at the end of the day, we still got square root of 2 over minus square root of 6. And yeah, there's the rest of the work if you still needed that. So, two different ways of getting the same end. Cosine of 5 pi over 12, you want to try that one on your own? Got some fractions here now, but think, okay, what are two measures that added together get me 5 pi over 12? If you struggle with that, give it the neighbor. So again, choosing pi over 6 and pi over 4, going back to that cosine formula. Cosines first, sines last. Pi over 6 and pi over 4 up there in quadrant 1, looking at those x values, and then looking at our y values. Multiply and subtract, and away we go.
Why'd you
If you go back to the cosine formula, this one's a little bit different. Yeah. So even though we were adding those two angles together, when we separate it out, it's a minus sign there. Yep, definitely make note of that. When you're subtracting, which you could do, you could subtract two angle measures, and if that's the case, then you add those when you separate them out. So cosine's kind of the opposite in that regard. Example number 2, kind of the opposite way now. Now they give us the expanded form. Now let's see if we can condense it down. 99 and 36 are obviously two that we want to use. Cosine and cosine came first, so which one of the three are we going to use, sine, cosine, or tangent, when we condense it down to one? Cosine. And the minus sign there, guys, again, almost makes us think we want to subtract these two. But if you go back to a cosine, when it's separated out with a minus sign, means when we bring them together, that's an addition sign. So there it is again, 36. 99 and 36, 135 degrees. And we can finish this thing by going to 135 degrees, finding our x value. Find the exact value. Number 3, find the exact value of cosine of alpha plus beta. Alpha and beta are just Greek letters that they use for angle measures again. We want to use different ones because, again, we got two different ratios here. Sine of alpha is going to be 5 over 13, and cosine of beta is going to be 5 over 6. And at first it's like, holy cow, one angle is hard enough, now they got two of them. This actually isn't too bad. Let's just start with that sine of alpha. Again, anytime they give you a ratio, it's a triangle, and they're given 2 out of 3 sides. Now alpha is told that it's in quadrant 2, so I'm just going to make a little sketch there of quadrant 2. There it is. I'm going to put my point there, draw my triangle. Sine, what over what? Yeah, and in terms of our sides, y over r. X is what we need to find. Pythagorean triple tells us it's 12. Excuse me. 12 to the left means that it's negative 12. So again, what we're doing is setting up all 3 side lengths because we're probably going to need them here in a little bit. Let's do the same thing for cosine of beta. Beta, it's given that it's in quadrant 4. One more sketch. Adjacent over hypotenuse, x over r. This one, Pythagorean theorem. Let's save ourselves some time. I think we've done that enough. It's going to come out to be 11. So again, Pythagorean theorem is how you come out with 11. And again, everything's kind of set and ready to go for us. It says to find the exact value of cosine of alpha plus beta. So that's our formula we're going to go to. Cosine of alpha plus beta. There we go. Cosine of alpha plus beta is equal to cosine of alpha times cosine of beta minus the sine of alpha sine of beta. And so in this case, we just can't go to the unit circle because obviously we don't have a radius of 1 anymore. This is something bigger. Alpha was the top one, So if it's cosine adjacent over hypotenuse, so negative 12 over 13. Cosine of beta, beta was our bottom angle. Cosine again, adjacent over hypotenuse, 5 over 6. It was also given that cosine of beta was 5 over 6, so we really didn't have to go hunt that down. But there it is anyways. Sine of alpha was given to us as 5 over 13. The sine of beta, opposite over hypotenuse, so square root would be 11 over 6. And that was negative. Anybody else catch that? Negative square root of 11. Negative, negative, positive 5 square roots of 11 over 78. And what an awesome number that is, right? They wanted exact, so there they go. Number 4 might be your most challenging one of the day right here. Inverse sine plus inverse tangent. Okay, there's a little bit going on here with this one. In a sense, what it is this is your u, and the inverse tangent of 5 over 12, that's your v. So u inverse sine v inverse tangent because again cosine of u plus v is what we want to use. All right, let's start with that inverse sine. Opposite over hypotenuse. The negative has to go to the 12. Because my hypotenuse is always going to be positive, so that's how I knew to go down to quadrant 4. Again, save ourselves. Does anybody know this Pythagorean triple? 12 blank 37? 35 is the answer. Tangent again is over on the right side of the unit circle. Both of them are positive, therefore it has to be up in quadrant 1. Again, it's not going to be to scale, but there's my 5, there's my 12, there's my 13. Cosine of u plus v means cosine of u times cosine of v minus the sine of u sine of v. Cosine x over r. And I'm actually going to see if you can finish it. Plugging in our values, x, y, and r, 420 and 60, 480 over 481. Let's do a tangent one. We've done a lot of sine and cosine, so let's do the one from tangent. Find the exact value of 165. Again, Be nice if 165 was on our unit circle, but it's not. So we're going to use these sum or differences to try to come up with that. We're actually going to do a difference one here. Again, probably multiple different combinations, but let's do a difference one. Let's do 210 minus 45. Both 210 and 45 are on our unit circle. Difference of those two is 165. Go back to your first page again. If it is a minus with tangent, it's tangent of u minus the tangent of v. So let's start there in our numerator. Tangent of u, which our u is 210, minus the tangent of 45. Down below in our denominator, 1 plus tangent of u times tangent of v. So in a sense, what it is today, it's a lot of plugging in and evaluating is what it is. Thing with tangent though, again, it's our ratios, all right? At 210, did we write that down? Y over x, what was it at 210? Yes, it was. 45. It was 1. Yep. So 1 plus square root of 3 over 3 times 1. Alright, that'll be pretty simple for us. Numerator is going to be where a lot of our work is going to be at. That times 1 is that. 3 over 3 to get our common denominators. Ready for your algebra portion today? Look at all those radicals and fractions. Now what? Plug it into your calculator. Times the reciprocal. You know what? I like both answers, but yeah, let's go ahead and multiply by the reciprocal. And the good news is our 3's cancel. And maybe we won't do all of it, but I will show if we rationalize this number. Multiply by the conjugate, right, of the denominator. Did a little bit of that yesterday. And again, I'm going to save you some work, guys. This will end up being negative 12 plus 6 square roots of 3 over 6. So I kind of jumped a step there. That's all right. We do have a common factor here between the 12 and the 6 square roots of 3, and that's going to be your 6. Just ran out of room. We actually finished with a couple of verifies. Cosine of 3 pi over 2 minus theta. And honestly, what it is just going back to the first page. If you go back to your formulas, the difference of your cosines, that was the cosine of u, which is our 3 pi over 2, times the cosine of v, which is theta, plus sine of u, so sine of 3 pi over 2, times sine of v. So again, we're just following the formula, doing what it tells us to. Cosine of 3 pi over 2. 3 pi over 2, I believe, is down at 270 degrees. Staying on the y-axis, therefore our x value is 0. The y value at 3 pi over 2 is -1. Anything times 0 is 0. And there's our negative sign. Last one. Little bigger one here, but that's all right. We actually get to finish with kind of a double summer difference here. We have the first one of sine of x plus y, and then we also get a sine of x minus y. Awesome. Let's start with the x plus y. Left-hand side, sine of x plus y. Go back to your formula. Sine of x times cosine of y plus cosine of x times sine of y. I am going to put that all in parentheses because that's all what that is equal to. Here's this minus sign now, minus, again parentheses. Now we got the sine of x minus y, difference of the signs. Alright, so as we start to simplify this set of parentheses really doesn't do anything for us. We got the sine of x times cosine of y plus cosine of x times sine of y. Let's go ahead and distribute our negative now. Plus sine of x times cosine of y. Double negative makes it positive, cosine of x times sine of y. How many terms do we have here? Maybe the better question is, how many plus and minus signs do we have? 3, right? So if we have 3 plus or minus signs, that means we have 4 terms. So we've got this one here, sine of x cosine of y. Any matches with that? Yeah, it's this third one right here. Think of all of that as x. X plus x is 2x. So 2 sine of x cosine of y. Cosine of x sine of y. Oh, hang on. Did everybody see the mistake that I made? Dang it. I was that close today. That close to not making a mistake. Dang it. Negative sign there. So actually, all of those two go away. And now we've got the cosine of x and sine of y to that. We've got 2 of those.